Right. This is the second worst spot to talk at conferences after lunch, and then the other one is before beer. That's probably even worse. But all right. Kubernetes and dragons in Linux kernel versus kernel, let's say kernel versus user-based tools. So what I'm going to talk about today is well, first of all, very quick look what Kubernetes and how it relates to the kernel and kernel space stuff. Some challenges we've seen and found, and then some of the lessons learned. So I'm Jussi. I work at Mirantis as a senior principal engineer, leading our K0's Kubernetes distro team. K0's is now CNCF sandbox project. All right. I've been starting this presentation now a couple of times with a quote. It's completely unrelated, but it's fun, and I bet there are days in your life when you actually are thinking about similar or same thoughts, that it's a miracle that anything works at all. And if you're not already thinking like that, I'm pretty sure that after the presentation you're gonna start leaning towards that direction. But let's see. All right, so user space versus kernel. And how does Kubernetes relate to that area of things? And especially now we're going to focus mostly on networking parts, but there are other similar challenges around other areas like storage and disks and whatnot. We're going to have a look at iptables, ipset, and then hopefully we'll have time for a bit of a Q&A. All right. So, as you know, kernel in Linux is the thing that provides all the necessary abstractions for hardware, for networking, all the primitive functionalities that your applications need, right? And of course, we all probably know that kernel can be kind of augmented by utilizing kernel modules. So you can somewhat dynamically add functionality, add features to your Linux kernel. And now, because we are mostly going to focus on networking parts, for example, netfilter is a kernel module, or actually set of kernel modules that provide things like packet filtering, translation, and those kind of things. How we manage the netfilter modules is through user space tooling, for example, iptables, right? So when you do an iptables, yada, yada, yada commands on user space on your command line, you're actually talking to the netfilter modules and to the kernel over a netlink socket. So the iptables tool that you call from CLI, it doesn't actually do pretty much anything. It just sends the information to kernel that, okay, here's the new rule. Do something with it. I don't care. And netlink is a very specialized kind of IPC-like socket thingy that you use when you want to talk to kernel. And that as a pattern is a very common. So iptables here is just an example. Pretty much all the other things work the exact same way. If you use load kernel modules, you use command line tool, right? But the command line tool doesn't actually do much. It talks to the kernel via netlink socket, and kernel actually does the magic, so to say. And by the way, I'm definitely not a kernel engineer, so I might be using wrong terms for things. So don't get too upset if you're super into kernel stuff. I'm really not. But how does Kubernetes now relate to this picture? If you run your Python web app application, you don't care, and you shouldn't have to care, right? Unfortunately, we do run a lot of components in our clusters that actually have to work at this kind of boundary between user space and kernel space. Every single cluster is running some sort of a CNI provider, right? Which has to cross the boundary. It has to configure iptable rules or load ePPF programs or whatnot. Depends, of course, on your CNI provider, how it does the networking magic. Your CSI might have to load some file system drivers on the fly. Your fancy new AI workloads will definitely have to work with GPUs on a kernel level to install drivers, verify things, and things like that. What we also need to remember is that if we think, for example, iptables, when did iptables come to Linux world? Way, way, way before we started to run containers per se. Way before Docker became popular, way before Kubernetes was popular. So many of these tools are pre-container era tools. So they are not really designed for container era clustering and a lot of containers running on the same node and those kind of things. And that's something we really have to remember, and that's something I'm gonna highlight in the presentation. All right. Let's meet our first dragon called iptables. He looks a bit scary, to be honest, and definitely looks more like a villain in the story and not the hero, unfortunately. iptables, as probably many of you know, is not the easiest things to work with. Whenever I have to do any iptable rules manually, I pretty much always end up boxing myself out from the system. And I'm pretty sure some of you have done the same thing, 1 or 2 times at least. One of the, I don't know, tricky, but one of the kind of features of iptables nowadays is that it can actually operate in 2 different modes, depending on your system configuration. So when I do an iptable rule, iptables -a and yada yada yada, it might actually go to what's called the legacy mode, legacy iptables rule set, or to an nftable rule set, right? Depending on your system configuration. And basically how it's configured in your system is usually by symbolic links. So if you go to your Ubuntu box, you'll probably, if you track down the iptable command, it's actually a symbolic link to somewhere, which is then symbolic link to either the legacy or nftables mode. So there's 2 different binaries actually, and your iptables command links to one of those. So that's how the OS is configured to select the mode. I think pretty much all of the latest distros and distro versions I've used, they pretty much all default to nftables nowadays, which is very good thing. But remember that we're running iptables on a host on a kernel level, right? What if I'm running CNI provider in a container which is using iptables? Which iptables is the container using? So that brings us to lesson number 1. If you have components if your host is using legacy mode or iptables mode, and your CNI or whatever you're running in a container, in a pod, is using a different mode, all bets are off. Some things might work, probably won't work, and things will fail miserably. Luckily, there's a community. Oh god, the font color is awful. Sorry about that. So there's a community wrapper project to detect the mode and force everything to use the same mode. But that actually would require that all the different components use the same wrapper and the same version of the wrapper, because they might have some small changes between versions in the selection logic and whatnot. And there are tools that are still not using it. Or at least weren't at the time we faced these problems, and I'm looking at you, Calico, with an evil eye. Calico used to have their own implementation of the selection logic, and it was slightly different than the community one, and well, you can guess what the end result was. Not good. And it's still not bulletproof. So you might have to tweak some components and say that, okay, I'm now forcing you to this mode. And don't try to do any detection or anything. But usually, at least on most of the CNIs, there is a flag where you can say that, okay, you're running now on iptables mode, and that's it. Okay. Like I mentioned, iptables itself, I mean, iptables by the command iptables that you run, it doesn't do anything. It takes the rule and sends it to kernel that here's a new rule for you. So the rules themselves are stored in kernel memory. And the netfilter modules use those rules then for the runtime, packet filtering, and translations and whatnot. But wait, I'm using iptables on a container again and on a host again. Are they sending the same rule actually to kernel, or interpreting the same rule at the user space level? This actually might become a challenge, because how iptables rules are typically managed is as a set of rules. Because iptables itself, it doesn't really have a nice way to manage individual rules. So with iptables, you can't actually go and say that, okay, I want to have the rule number 10 deleted. You have to actually match the whole rule if you want to delete it, which might be difficult in very dynamic environments like Kubernetes. So that's why at least some, or maybe even most components that deal with iptables, especially in the world of Kubernetes, they have this pattern that read all, modify things, add things, delete things, and then write everything back. And of course, there's the transactional lock, the xtable lock also involved. So it locks first and then releases the lock afterwards.
What is it in Kubernetes that allows container to talk to host?
You have to add enough privileges to your container, and that's it. You can talk to the kernel.
But is it the CNI that
It's in this case, it's typically the CNI that needs to talk to iptables. Yes. Okay. Or it might be a network policy controller, which is quite often a part of CNI provider. Or envoy proxies or Linkerd's, or I have no idea whether they actually talk iptables, but they are network related components, so they might.
Yeah, the sidecar usually hijack traffic by IP.
Yeah. All right. But why would versions matter? So let's assume that I have iptables version 188 writing a rule. This is actually a Kubernetes related rule, as you can see, which is basically to tell that let's mark all the packets with this byte, and then jump to drop. Which in this case, because we're marking the packet, it doesn't actually drop the packet. It's just marking, basically allowing the network policy controller to add rules to match this byte. And then do further filtering based on pods and namespaces and whatnot. Right. So very harmless helper rule. What if I have now, because remember iptables is a pre-container era tool. So it's in a pre-container era, you have only one iptables at your host, right? What if I have a different version now in some pod, some CNI container or envoy proxy sidecar or whatever running? So if I actually read and write back the same rule with version 187, notice there's a small change. Hands up if you figure out what's going to happen with that rule. Okay? Wasn't a fun day at all. So it really, because we read the rules with the different, slightly different patch version of iptables from Linux kernel, they get interpreted different, and we write it back. So that rule really means drop every single packet. So now you're locked out from the system if it's a remote system. So yeah, that's me on that day. We of course, because we are part of the community, we want to also make the community better, and so we reach out to kernel netfilter developers, and I think Phil is one of the main developers, at least if not the lead developer. He basically said that they don't have any guarantees between versions. Which actually, if you think about it, it actually makes sense. Remember, it's a pre-container era tool. It's designed in a way that you have one single iptables version on your host. Why would they care? So yeah, I'm sure that version incompatibility bug is not the only one that we're gonna see. So another lesson learned: ensure that all your different components that are using iptables are using the actual same version of iptables. So now we have to ensure the same mode and the same version. I guess the obvious question is that, can I really pin all the versions? Maybe, maybe not. But at least test your combination before pushing it to production. Don't update randomly on production. Well, you shouldn't do that anyway, but here's one more reason why not to do it. Just an example in K0s, which is a single binary distribution for Kubernetes. We actually embed iptables into K0's binary itself, and we ensure that that version of iptables is consistent with every single other iptables related pod that we might have, like CNI providers and envoys and whatnot. So we basically pin the iptables version across K0's cluster. I mean, on the components that we control. If you deploy your own stuff that are using iptables, of course, that's not our concern, but just know that there might be dragons there. Lesson 2b, this is actually a super fun quote from Jerome, and I guess he overheard it. So when you're building a team for gaming, you need a tank, a healer, damage dealer, and then someone who knows iptables. Which is true. And at least I'm super lucky that I have those kind of guys in my team. So made life a lot easier to figure out that what's actually going on. All right, ipset. Anyone heard about ipset even before? See some nodding. So in short, iptables, ipset. It's basically a tool to efficiently manage set of addresses. So as an example, we have set of pods from a deployment that you expose via service, right? So a service has endpoints for all these pods. So that could be a set of addresses, for example. And what ipset really allows within the kernel, within netfilter, is super quick lookups for these addresses. So instead of in your iptable rules, instead of writing 3 rules that match that, okay, it goes to this spot, this spot, this spot, you can actually write 1 rule to say that if the address matches a set of addresses. So you don't have to do like individual rules in a very simplified example. And of course, in kernel, they are the sets are stored in hashes and bitmaps and other very efficient data structures, like everything in kernel basically is. But again, it's another pre-container era tool, which means it's not designed to run multiple instances of ipset on the same host. And again, versions matter. So in your cluster, multiple components can manage actually the sets. You might have firewall running on your host level. You might have CNI using ipset. You might have network policy controller, envoy, whatnot. In Linux 6.2 kernel, they added a new attribute, this bitmask parameter for ipset. And older versions of ipset just cannot cope with rules that are written using the bitmask parameter. So now if you have newer version writing sets, an older version trying to read those sets, the older version just says, no, don't understand, cannot do anything. And you're, in this case, and I'm looking at you, Calico, again. The Calico bot actually just was in a crash loop. So basically, all your cluster networking is borked. Another fun day. And as you probably can imagine, figuring out the root causes for these kind of things is not really trivial either. What we ended up doing basically is reading the kernel source code and trying to figure out, okay, this is the error string, grep that, and then track the hints. Okay, so lesson 3, ipset, try to ensure the same version. And again, in K0s, we actually pin now iptables and ipset on the components that we control. So we are using a lot of pre-container era tools in our cloud native stack. And the whole stack kind of builds on top of those kind of things. Many of the CNI and network providers are actually moving away from IP tables nowadays. So many are doing ePPF, which is super nice and super good. I don't know ePPF that well, but it's again, ePPF is very similar in a way that you need, from your user space, you actually need to load a program dynamically into kernel, which kernel executes. Are there similar dragons in that borderline? I'm pretty sure there is. Yeah, versions can be very, very picky. Test everything before you roll it out to production, even if it's a very, very slight kernel patch version change or Calico, other CNI provider patch version bump, because there are dragons in these compatibility, version compatibility things. And ensure that you actually have enough low-level experience and low-level knowledge in your team. Because otherwise, when you hit problems like this, if you only know how to write Python web application and maybe write a Docker file for that even, you're going to have difficult times to debug things like this. So, the quote. It's a miracle anything works at all. And I'm really, well, not really, but partially at least joking here. But somewhat partially also serious about things. Thank you. And I'll be hanging around if you want to chat afterwards too.
In a nutshell, how does K0s inject those versions into the different components that it's actually running? Because K0s runs on an environment that it actually does not fully control, right? It runs on an OS. So how does that happen? In a nutshell, if you have 2 or 3 minutes.
So in a nutshell, we can't control the host version of iptables, of course, because that's depending on the OS distro and packaging and whatnot, which is, we don't touch that. What we control is because K0s embeds iptables and a specific version of it, which means that all the components that we manage, like kubelets and containerists and whatnot, they are using our provided version. Plus then all the images that we build and ship, like Calico and kuberouter and other things, in those we actually pin the version, which we control in a nutshell.
Thank you.
Thanks.